Hey everybody, it's Mr. Carr again. Today we're going to continue Unit 3 with what's called function notation. So 3B, function notation. All right. So we talked about what functions are. It's a way of relating inputs to outputs. And they have to have a very specific definition. All right. So function notation is the proper way to, to write functions. Okay. Typically, it uses something like this, f of x. So I read this as f of x. Okay. So this is related. This is related to our functions right here. Okay. So when we write our functions, it's actually very similar to equations that you've already done. So remember what we talked about before. So a function is a relation in which each element of the domain corresponds to exactly one element of the range. Okay. Every input maps to one output. So what that means is the inputs cannot repeat. So if you have the same input going to two different outputs, that's not a function anymore. So here it is. Here's our function notation. We start with an equation like this. Y equals 3x plus 2. You've probably dealt with that. Okay. So when we go through this, here's our magical change from equation to function. We're going to replace the y here with f of x. And that's it. They're exactly the same thing. So y, we're going to change y into f of x. What this does is it's a notation for functions. So we read this as f of x, which means the function f of x. In this format, x is always, or whatever this is going to be my input. So when you look at the function itself, that x value represents the input. This whole thing is going to be the output. Okay. So for example, of this case right here, f of 1, that's how I read it, as f of 1. What I'm asking for is, what is the output when 1 is the input? So what we do is, if I request you, if I'm trying to find, or you're trying to find the f of 1, you're going to replace the x value with 1 because that's our input. So I can finish this problem out. Oops. So that f of 1 is equal to 3 times 1 is 3 plus 2 there. So f of 1 is 5. So this is what I'm stating. When my input is 1, my output is 5. That's what this part of the notation means. Okay. So for this first example, all we're going to do is just rewrite these. Okay. We're going to rewrite these, and it's going to be really tricky, very difficult for part A. Ready? Y there turns into this. Again, only difference between an equation and function is I'm changing this into this. It says here part B, it says to give, let's look at this part 2. It says give each function a different name. So I don't always have to use f. Sometimes we like to use different letters for the functions just so we can change them. So in the first case, it was f of x. In the second case, my input is still x here. So I'm just going to change it to a g. So I'm going to say g of x equals -1/2 x minus 7/2. And again, that's all I'm doing is swapping out this for this. Okay. X is still going to be my input, so it's still going to be g of x. For the next one, I'm going to go with h instead of f or g. So f, g, h. We'll right in order there. However, look at my input. My input is t. So I don't want to do h of x anymore. I want to do h of t. Remember, this is related to inputs and outputs. So in this case, h of t equals 8t squared. All I did was change out the y, but I need to make sure that my inputs here match up to what the input is here. So it's always like t and t like that. Okay. So that's our first basic idea of setting up our function notation. The next step is evaluating. So in the past, here's what we said. Solve the equation for y, given the equation y equals -5x minus 1, and given that x equals 2. And I don't like solve. We typically said evaluate. Okay, we said evaluate the equation y given the this equation and the value x equals 2. Okay, so typically what that means is you would do this. Y equals -5 times 2 minus 1. Then go through your order of operations. Now it's the same exact thing, but with my function notation. If I say find f of 2, given this function, it's the same exact setup. F of 2. So I like to look at that. That's my input is what it's saying. So I go here to my function. I'll do just like I do before. I'll leave open parentheses there. Then I go back and put in my 2 right there. So f of 2 is going to evaluate -5 times 2 is a -10. So that means f of 2 equals a -11. Now, because we're dealing with function notation, this is my proper formatting. You want that to say f of 2 equals -11. Okay, because that with the function idea, we're saying the function of f when the input is 2 equals -11. All right. So that's what we're stating with this. It's clear communication for anybody else looking at this answer here. Evaluating more functions. Just run through these a little bit quicker now. Only real tricky part about this is making sure you understand that which function you're dealing with. So f, g, f, h, g, h. Okay. So when you look at that, so we got f of -5. So it's going to look like this. So here's my f function. So it's going to be -2. I'll put parentheses plus 6. I'm just going to do them all where I set it up. G of x here. Okay, so g of 3. So I'm going to go to the g function. So that's going to be about parentheses squared plus 2 times parentheses, whoops, -1. Okay, f of 9, that's back to the first one. So f of 9 is going to equal to -2. We'll do parentheses plus 6. H of 3, this is my h function. So h of 3 is equal to -4. We'll do parentheses squared minus 2 times parentheses plus 5. Here's g again. So g of -6 is equal to do parentheses squared plus 2 times parentheses minus 1. H of -4 is going to equal to -4 parentheses squared minus 2 times parentheses. And I'm losing space here. So let's fix that. Oh, lost a 2. Keep that there. And then minus 2 times parentheses plus 6. All right. So I just want to set all those up because what we're doing, I'm just kind of identifying which function goes with which problem. Now, in each case, remember, this is my input -5. That's going to go right here. So f of -5 is equal to -2 times -5 is a positive 10 plus 6. So f of -5 is 16. Okay, g of -3, I'm going to plug in my input of 3, put it into all those spots where the input goes. So g of 3 is equal to 3 squared is 9, plus 2 times 3 is 6, minus 1. So I did my exponents followed by my multiplication. Now I could do my addition and subtraction. 9 plus 6 is 15, minus 1 is 14. F of 9, I'm going to put 9 in my input spot. So f of 9 is equal to a -18 plus 6. F of 9 is going to give me a -12. Okay, h, we've got -4 times 3 squared minus 2 times 3. Again, this is my input, so that's what goes in those two spots. Remember your order of operations. We're going to do exponents first. That's 3 times 3 is going to give me 9. So h of 3 is equal to a -4 times 9. Then I'm going to have minus 2 times 3 is going to give me -6 plus 5. H of 3 is going to give me -36 minus 6 plus 5. So -36 minus 6 is going to give me -42 plus 5 is going to give me a -37. Okay, so g of -6, we'll put that there and that there. So when I do, let's split some of these up here. I'm getting a little bit crowded. Okay, so when I got -6 squared, that becomes a positive 36. That'll be a -12 and then -1. So g of -6 is going to give me 36 minus 12 is 24. 24 minus 1 is going to give me 23. All right, and the last one, we'll put -4 here and -4 here. So remember, I got to do my order of operations. So this is going to go first. Exponents for that one. So -4 squared is positive 16. So it's -4 times a positive 16. Here, I've got -2 times a -4. So that's going to give me a positive 8. Then I have positive 6 there. So h of -4 is going to equal to, that's going to come out to a -64 plus 8 plus 6. So we just add these together left to right. Okay, so -64 plus 8 is going to give me -56. -56 plus 6 is going to give me a -50. All right. So that's evaluating it. You're given a function, given an input, plug it in, find your outputs. From a graph, remember, we can represent our functions a variety of ways. We represent the functions as equations. Well, now we're going to represent them as a graph. Here's my function here. When we look at this, we're trying to interpret what these mean in terms of the graph. If I say k of -1, I'm looking for the output. And what I'm really saying is, what's the output when the input equals -1? So on a corner grid, this is my input. Remember, X is input, Y is output. Okay, let me get rid of that. I don't like that point there. So if I go to -1 right here, the output is wherever the line is. It's up here. So this is my answer right there. So that's the point, -1 and then +2. So according to that, that means my function is, my output at k of -1 equals 2. Okay, same idea with k of 3.5. My input is 3.5. So I'm going to go 1, 2, 3.5. And then I come up to the graph is right about there. Okay, I'm going to estimate as best as I can. So that's going to be 3.5. That was 1, 2, 3.5. Okay, so I'm going to say it's that. Find all x's if k of x equals -1. So this is telling me that my output equals -1. This one's a little bit different. If I look at the graph, remember, output is the y-axis. So I'm going to come down here to -1, and let's kind of draw this in. Like, I like drawing it in this way with a horizontal line. Any of my outputs of -1 is wherever I cross. So it does it twice. So since I'm crossing there, that's 2x values. X is going to equal to, it looks like a -2. And so we got -2 and a -4. Okay, so two types of problems from a graph. What's the output given an input? What's the inputs given an output? Okay, so it's just two different things. So in this case, find the output. Here's the input of -1. Here's the output of -1. Find the inputs. From a table, kind of similar. We're just interpreting what these mean. So h of 6, that's my input, which means that is x, right? Oops, I don't want to put x again. I want to put input. H of x is going to be my outputs. So if I look at that, my input of 6 is right here. The output is -3. Straightforward on that one. H of -11, same idea. My input is -11. So I go here, my output is -1. The other one is different though, because find x if h of x equals -2. So that's my output. So I'm going to look here and I look, oh, there it is, -2. And that's the only -2. So that's going to go to a -4. So x equals -4. So remember the proper notation. I'm stating h of 6 equals -3, h of -11 equals -1, h of x equals -2 when x equals -4. Okay. All right, that's it. So that's now until you try nows. I know it's a good amount of information today, but remember, everything is about input versus output. We can represent our functions in a variety of ways. We've done it with equations like this. We've done it with graphs. We've done it with tables. You just need to interpret h of x, f of x. Okay. The x is your input. What's inside the parentheses is the input. The h of or f of, that's your output. Okay. So that's it for 3B. Take care, everybody. Talk to you later.